Can you tell me anyone? Previous class, means yesterday I already discussed na, that AR is the radial component of acceleration, and A theta, this is the transverse component of acceleration, right? So it is r theta double dot plus 2 r dot theta dot na. So these are the and the thing are same, that is summation of force is equal to summation of mass into ar, and when summation of force along transverse component, summation of mass into a theta na. This thing already discussed in the previous class. This is the for polar coordinate. Similarly, for normal and tangential coordinate, for curvilinear motion, for rectilinear motion. And after that, we have started the work and energy method, where I already discussed about that the potential energy is nothing but the tangential force into displacement, right? This thing I already discussed. Now, today we have started potential energy and the work energy equation. Okay, so in the previous class, I have told you that any particle, if it moves on a curvilinear path, right? Suppose this is a point 1, this is a point 2, and if a particle move through this point, then the potential energy, or we can say the work done, is nothing but the mv dv, which is half of m v2 square minus v1 square, means velocity at point 2 and velocity at point 1, right? And this indicates that the kinetic energy is always positive, right? This is the equation of kinetic energy, right? Half of mv square. So now now we have started the potential energy. So potential energy in terms of gravity and elasticity, here if we consider, if we consider gravitational potential energy, we consider it Vg, and uh, elastic potential energy we consider as Ve. Okay, then then the work which is done on the any, suppose they have any spring mass system. Okay, then the work done which is done by this uh, this mass on this spring is deformed as well as it restored, so it is called the elastic potential energy. Actually, when you see any spring mass system is there, due to its own weight, it will move downward, and when we release this mass, then it will again restore its original position. So in such a manner, this is actually called, means the amount of energy, potential energy, which is stored by the system, that is called the elastic potential energy. Okay, so now if we write down the work energy equation, so without considering that elastic body, we can write that the potential energy due to the gravity plus change in the kinetic energy is the work done. Okay, it means what? It means the, it means the, with considering elastic body, and if we say that you want to the work of all the external forces, we can say it work done for all external forces other than gravitational force and spring force. Okay, if we say like that, then we can write u1 to 2 is change in kinetic energy plus change in potential energy plus change in gravitational energy. This one is the potential in elastic energy, potential this one is the gravitational energy, means the potential energy due to the gravitation, potential energy due to the elasticity, and this one is the change in the kinetic energy. So summation of all these thing is indicates the amount of work done. Okay, so up to this is, we can say, as a I already told you, that there is a three method. So that is called the work and energy principle. Okay, up to this means the total work done is nothing on any spring mass system, is nothing but the change in the kinetic energy, change in the potential energy due to the gravitation, change in the potential energy due to the elasticity. Right, now come to the third part, that is impulse and momentum. Okay, so in impulse and momentum, see, under that we can start linear impulse, linear, हाँ सर बोलिए, मॉर्निंग मॉर्निंग, linear impulse, हाँ ठीक है आज देखते हैं ना, linear impulse and linear momentum. So under linear impulse and linear momentum, see, generally any curvilinear motion, in the previous class I show you one diagram, that is any curvilinear motion of any particle, if it is the path, for example, and if you take a coordinate system like this, like this, and take a position of a particle, take the position of a particle initially, suppose this one, okay, and take this distance, sorry, take this distance as r1 with this velocity of that particle is v1 at time t1, means when the time t1, at the time that particle moves along this curvilinear path with a velocity of v and at a distance from the origin is r1. Okay, now if this particle move in this direction, move in this direction and go in this position now, which have a distance from the origin is r, if it is, and if the particle have a mass of m, and if we apply the all the forces, consider some summation of all forces on applied on this particle, so here have two component, right, which is one is along tangential of that curvilinear path indicates the velocity, so that is the v, which is nothing but the r dot, right, and another one is the perpendicular to that path, which is nothing but the velocity gradient, derivative, or we can say acceleration. So from these two position we can say that any general curvilinear motion in a space of a particle of mass m with a velocity is r dot, and its tangent is always that path, means the velocity is the tangent of any curvilinear path, and the resultant of all forces, hmm, on that particle, if we consider that is a mass m, then we can say summation of all force which is acted on a particle of mass m is the derivative of time. So it is the ddt of mv. Okay, and if we denoted this mv as g dot, then then This G is the linear momentum. Okay, so G is the linear momentum, so that the G dot is the ddt of mv, which is the summation of, so we can write summation of all forces is equal to the G dot. Clear up to this? So this equation actually, what it indicates, this equation actually states the resultant of all forces acted on a particle is on a particle equal its time rate of change of the linear momentum. Okay, now linear impulse and momentum principle. See, up to this, is it clear, right? Up to this, anyone have any question? Hello, is anyone is there? Please reply then. Please reply anyone. Is anyone is there? Student?
Yes, sir.
Till now any confusion you can ask or I can proceed. Which one you prefer? Tell me. Okay, so let's go. I proceeded. See, this one is the linear impulse and the linear momentum. So linear impulse and linear momentum principle is what? The effect of the all the resultant force, the effect of all the resultant force on the linear momentum of a particle over a finite period of time. So if we say like that, finite period of time means if this position is t1, and when this particle suppose go here, and here the velocity consider v2 time t2. Okay, and radius is r2. So if this is the position, then we can write it is the g2 minus g1 is equal to del g. So at time t2, this g2 indicates at time t2 the linear momentum, the linear momentum of that particle is g2, and similarly the linear momentum of that particle is g1 at the time of t1. Okay, so the product of the force and time is defined as a linear impulse of force. Okay, this del summation of all f and summation of dt. Okay, that is the product of these two, time and force. So the product of force and time is defined as the linear impulse of force. Means in this equation you can see that the total linear impulse on mass m is equals to the change in the linear momentum of mass m. Clear? Up to this, is it clear? Any question you can ask. Means I could not understand na, if you're not saying anything, how can I understand? If anyone have any confusion, you can ask. Should I repeat this thing or should I tell something?
Sir, repeat again, sir.
Okay, which portion? Means from beginning I have to repeat, or which some specific portion is there? Means should I repeat the impulse portion part or the work energy part? Which one you want? See, I just started na impulse and momentum. Which portion you want? Tell me.
Momentum, sir. Linear momentum.
Okay, okay. See, in the last class, actually, I told you that any means the motion of a particle in any curvilinear path. Okay, so there we have find out that the work done in that curvilinear motion, curvilinear path, is the change in the kinetic energy only. Okay, means I already told you na, this one, that u12 is the integration of mvdv is half of mv2 square minus v1 square. Okay, now consider this thing that any particle which move along this path, na, any particle which this red line indicates red, see the red line, this is considered the path. Okay, so this is not a straight line na, so that's why we say this is a curvilinear, this is not a straight line. So consider at time t1 this particle is here and the distance from the origin O is r1 and have a velocity v1. Consider this. Okay, now consider after some time, means when the time t2, consider that particle move along this path and go to this position, and then the velocity here is v2 and the distance is r2 and the time is t2. Okay, so this particle is not move automatically, it means there should have some applied forces, right? So that the applied forces due to which that particle move na, so we can equalize each other, that is the summation of all forces. This is indicates the summation of all forces. Suppose from here to here na, when that particle moves, suppose three or four forces are there, so we cannot say, we cannot write now all the force f1 plus f2 plus f3 plus f4 dot fn, huh? Lots of forces are there, we can simply define this as a summation of f. So the summation of f means the resultant of all forces is nothing but the change in the velocity of that particle. If that particle have mass m, then the mass into velocity derivative, this one. So this, as the, this is a independent function, so we can put this also inside, then we can take this mv ddt, this v dot na, you know, ddt of v we can write is v dot na, so that's why we can write that ddt of mv. Now see, if we denote this mv by a new term g, and we say that g is a linear momentum, then ddt of mv is nothing but the ddt of g, and any derivative we can write as a g dot, means any derivative, suppose velocity and velocity derivative, so v dot, and g linear momentum derivative g dot, like that, huh? So we find that the summation of all forces acted on any particle is nothing but its change in the linear momentum. Up to this, is it clear, right? Up to this, is it clear, right? Linear momentum means up to this. Up to this, any question?
No, sir.
Okay. See, now this is called, this actually called the linear momentum principle. Okay. Now if we say that linear impulse principle, so what is a linear impulse? Linear impulse is when that force acted on a particle for a definite period of time. Understand? For a definite period of time. One, then suppose this particle is here na, so t1, and this particle go to the new position here, so the time required to go from this position to this position is the t2. So t1 to t2, for this specific interval, that all the forces applied on that particle of mass m, if it is, it means the integration of t1 to t2, summation of f of dt is nothing but the g2 minus g1. So change in the linear momentum, right? So here is linear momentum principle, which is summation of all force is equal to g dot, and here is integration of summation of all forces with respect to time is the change in the linear momentum. So these are the two equation. One is linear momentum principle, another one is the linear impulse principle. Okay, up to this is it clear? Now it is clear, right?
Yes, sir.
Okay, so the next part is, see, there have the linear linear part we have covered. So now the come to the angular impulse and the angular momentum. So here what we have to do, see, okay, let's draw first. Consider a particle p which moves along the this curved path. Okay, consider particle move along this curved path, and now the position which I drawn here, that is nothing but the this present position. If it is, then one is, one is along this and along this. So this is the linear momentum, and this angle is create suppose theta. Now the thing is the moment of the linear momentum. Try to understand very clearly. You all know the linear momentum, which one we define as a g, right? In this linear principle and linear impulse momentum, right? Now the try to understand very minutely the momentum, sorry, the moment of the linear momentum, moment of the linear momentum is g, which is denoted as mv. So the moment of the gv mv is linear momentum about origin o is defined as the angular momentum ho. Okay, so you all know that if when we write the any momentum moment equation, moment is equal to r cross f na, normally we write na, in the static part we have shown there, right? So here we have what we have to do, instead of m we put ho, instead of r we have to put normal distance, means same as r vector h vector into, instead of f we have to put here mv, where that mv is also a vector. Okay, so you know this equation, moment is equal to r cross f. Similarly we have to put here also, and this is the your present equation. It means the moment of the linear momentum about the origin O is defined as a angular momentum. Any question, anyone here? So if why 2 to 1 came now? See, from the next day, if I see I have taken my class within 20 minutes, I will lock the this what can say Zoom. Okay, you came now and it is not a proper way. See here, if we have to find out the angular momentum, then the procedure is the moment of the linear momentum about the origin is the defined as the angular momentum, and that angular momentum we can show here. See, this is your R and this is your mv. So R and mv, so the angular momentum is nothing but ho is equal to R cross mv, right? Which direction is this one, and it will rotate in this manner na? You can see here. So the angular momentum is a vector, right, which is perpendicular to the plane. If we say, see, this is R, this is mv. If we draw this plane, then we can easily say this. If we consider this plane, then we can easily say this ho is perpendicular to that plane. Okay, now in such a manner we can write h0 is equal to R cross v, and where if you write in vector in the matrix form, then you can easily write h0 is nothing but this R cross mv na. So m I j k x y z vx vy and vz. This xyz for this R, and this for v vx and vy and vz. Okay, now come the similar to the linear impulse, come to the angular impulse. The funda is same. Here what we have to do, here you can see we have done that time derivative of that mv is the g dot, which is indicates the linear momentum principle, right? So here what we have to do, simply we have to put for the summation of all moment, previously summation of all force, here summation of all moment is nothing but R cross summation of all forces, which is nothing but the R cross mv dot, right? Summation of f you know na, that mv dot. So before that R and R. So here you can write h0 is equal to R cross mv. So h dot, if we write, then R dot cross mv plus R cross mv dot. Okay, this is a simple derivative, and R dot is the v. So v cross mv plus R cross mv dot. And you know the same thing, if we multiply this term na, this should be 0 as the cross product of the parallel vector. This is one vector, this is one vector, same vector na, so that should be 0. So we can find that h dot is nothing but R into mv dot. And see here, summation of all moment also this R cross mv dot. So what it means? It means summation of all moment is nothing but the rate of change of angular momentum. Like similarly, the summation of all forces is the rate of change of linear momentum. Na? Previously, what we find out? Previously, summation of F is equal to G dot. Na? Previously, we have find out this one. This is the rate of change of linear momentum is equals to the summation of all forces acted on that particle. Similarly, here we can say the summation of all momentum is equals to the rate of change of angular momentum acted on that particle. Okay. Now, if this linear, sorry, if this moment is acted on that particle for a specific interval of or definite interval of time, means we can write integration of t1 to t2 summation of m0, right? And with respect to time derivative. 2:30, why you are come so late? I told you that if from the next class it is happen like after 20 minutes you just want to add here, then I am not attending this thing. Okay. So see here integration of m0 of dt is equals to the nothing but the change in the angular momentum only. Sorry, this one. T2 to T1 means if that particle, if that particle can, come from this position, this is the position 1, and go in this position, suppose this is a position 2, then 1 to 2, if this particle will go, then it will give us the change in the angular momentum, and this is the del h, we can write it h. So 2 here also we got the 2 equation, right? If a moment, summation of all moment acted on any particle for a specific interval of time, then that is equals to the change of angular momentum. Okay, same thing. Now or in other word we can also say that the product of the moment and time, this one is the moment and this one is the time, so the product of the moment and time is defined as the change in the angular momentum, or we can say this one as a change in angular momentum. Angular momentum is the impulse, angular, so we can say angular impulse, angular impulse. Okay. So up to this, anyone have any question here? It is a similar type of the linear momentum. Only instead of force, it has come the moment, and instead of linear momentum, that is a mv, here come the r cross mv, right? Means which is denoted as a h. So up to this, is it clear? If anyone have any confusion, you can ask. See, I could not understand. Means if anyone have any confusion, if you do not tell, then how can I understand that thing, na? So, okay, let's start one numerical example. And next day I will start the impulse and some principle. We can say that is a D'Alembert's principle and the momentum principle are there. So next day we can do that thing. So numerical problem. See, suppose in suppose in the question paper it is written like that: any velocity is given and with respect to time, and if it is said like that the experimental data of for the motion of a particle along a straight line measured, the velocity varies from position to position in the coordinate system. Okay, so we have to find out the acceleration when the s is 20 feet. Okay, so here what we have to do, see, the acceleration is dv by dt, and it said that the velocity varies position coordinate. So if it is, then position coordinate means we just convert it this dv by dt into dv by ds, as the velocity varies the position coordinate means the space with respect to position, right? So ds by dt. So here we get a is equal to v into dv by ds, right? Now, if in this graph it said like suppose in this graph it is said like this is your position A, and this is your position B, this is your position C, this is your position D, this is your position 0. And here if it is right 2, 4, 6, 8, and time is considered 10, 15, 20, and 25. So to solve this type of problem, what we have to do, simply put the data here. Here data is, see, dv means the difference between the point va to vc. Why I have taken this one? Because in the question it is written that for s is equal to 20 feet, so s is here 20. For the 20, see in this graph as per the question, for 20, this one, your velocity is only the A and C. Okay, so if you take VA is VA by SA minus SC. So VA as per the question is 8, right? At time is equal to 20. And VC at time is equal to 20 is 4, right? So 8 minus 4 by 25 minus 15, and the velocity is given what, 6 in between, na? Means between the 15 and 25. So what we have to do, simply 4 into 6 by 10. So it is 2.4 feet per second square. So it is understand now. You have to solve the problem in such a manner. If they given in the data in terms of graph. Anyone have any confusion in this question? You can ask. Have you understand this problem? Yes or no? Please tell me. See, in the exam, normally given this type of graph, and they said like that you have to find out the acceleration when the code in this coordinate s is displacement is 20. Okay, the if they said like that, so what you have to do at s is equal to 20 if given here, see here it is s is equal to 20 no, but here have not any given the acceleration. So to find out the acceleration you have to do one backward and forward. So means 15 data you know, 25 data you know, so 15 plus 25 by 2 is a 20. So in such a manner you have to find out. So that's why I have taken as here in the question say 20 na, so we can take one data for 25, one data for 15, and if we sum up this thing, then we can find out the acceleration for 20. So that's why I have taken one is a, one is c, means this position and this position. So on 25 the velocity is 8, on 15 the velocity is 4, and the displacement is 25 minus 15, so 25 minus 15 and x. So in such a manner we can find out the accelerate particle. Okay, is it clear? Yes or no? Please tell me. If confusion you can ask. Okay, then I end my lecture here for today. So should I means give this note what I have written now in this WhatsApp? Is it is required for all of you, or you have already written this thing?
No, sir.
We required, sir.
Okay, then I give it to WhatsApp. Okay. Okay, thank you.